Welcome. In this lesson, we are going to use properties of logarithms to solve more complex logarithmic equations. In other words, we actually have to use this difference of two logarithms property, where if we are minusing two logarithms that have the same base, we can write it as a single logarithm of the first argument divided by the second argument, or x over y. We might have to use the product rule, or the sum, where we add two logarithms, it will equal the product of the two arguments. We might also need to use the exponent rule, where we bring in, or the power rule, where that x will come in and become a power on the y. Or maybe we need to bring it out to do algebra. And always remember how to convert between a logarithm to an exponential. Log base b of y equals x is just b raised to the x equals y. This is the base, this is the exponent, this is what it equals. So for this particular problem here, what I did is, again, that difference means I'm going to take this first u and I'm going to divide by 5 and do it as a single logarithm base 9, because they're both base 9, equals 1. Now I convert this to exponential form. I take the base of 9, raise it to the 1 exponent, equals u, that's a u, over 5. Now multiply both sides by 5, and we get a final value of 45 equals u, because I multiplied both sides by 5 to get rid of the denominator. And that is our final answer, 45. And all of these will be similar to this. So take a moment and write down all these blue equations and these conversions and these rules for logarithms, so you'll have them as you move forward. So pause and write them down. So here, again, we're going to do the difference. So again, it's going to be log base 3 of x over 6 equals 4. So again, I combine those two logarithms using the difference rule, or the power, or it's the product rule. And then we get 3 to the 4th equals x over 6. And then it's a simple equation. 3 to the 4th, by the way, is 81. Be careful you do it as a power. Don't do 3 times 4 and do 12, because that's what popped into my head. But it's 3 times 3 times 3 times 3, which is 81, equals x over 6. And again, you might have to use a calculator to times 81 by 6, but we get 486 would be our final solution, 486. So I'm going to jump ahead, because this is similar to the last one. Here we have the addition, or it's the product rule. So again, I'm going to do it as a single logarithm base 8 of 4z, because the order we multiply doesn't matter. So I just put the 4 in front of the z, because it's z times 4, or 4z, equals 1. Again, it's a base 8, so 8 to the 1 power equals 4z. And then obviously we divide by 4 and get a z value of 2. And that's because we use the product rule. Again, 6 times z will be inside, so 12 to the 6z equals 1. Very similar to the last one. I'll let you finish this one. Okay, now here's where we got two logarithms on opposite sides of the equation. So what we do is we either add or subtract one of them over to the other side, so we can use the power the product or difference rule. Obviously, since they're both positive, we're going to subtract. So what I'm going to do is I'm going to go 0 equals the common log, by the way, of 12 minus the common log of 4z. Well, now I can combine it into a single logarithm. I get 0 equals common log of 12 divided by 4z, which that reduces to 0 equals the common log of 3 over z. And now it's common log, so it's 10, base is 10, raised to the 0 power, this is my exponent, equals 3 over z. Well, 10 to the 0 power is 1, 1 equals 3 over z, multiply both sides by z, and we find out z must be 3. So again, we had to actually bring all the logarithms to one side through addition or subtraction. Just don't divide it over. They don't cancel by division or anything. So be careful with that. This one will be exactly the same. So just kind of follow the same process on this one. Just minus over the log 5 of t. You could actually minus the log of 5 over to the left side. Would work just as well. Now again, same exact process, except our algebraic expression afterward will be more complex. So I worked out the steps very quickly, so I didn't have to waste time on the video. But basically what I did is I minused this log that's on the left over to the right, used the difference property or the quotient property, made it a single logarithm base 8 of 3t minus 2 over 2t. Now I took a to the 0 power. This is my base, this is my exponent, is equal to this argument, 3t minus 2 over 2t. 8 to the 0 is 1, don't forget that. Multiply both sides by 2t. That's 2t equals 3t minus 2. I actually minus the 2t this way and added the 2 that way to get t equals 2. And we get a t value of 2. This one will be very similar in nature, so I'm going to jump ahead, see if they get any harder. Again, this one just minus, oh, this has an exponent, so let's do this one. I hope that last problem recorded. I don't know if I clicked the unpause button, but let's do this one where this one has a squared again, okay, which would have been similar to the last one, except this is a full quadratic. What I've done is I first minus the log of 8 to the left side so I can keep the y squared plus 2y on top of the fraction when I combine the two logarithms. Since it's subtraction, it becomes the y squared plus 2y over 8 as a single common log equaling 0. Now I change it to exponential form, 10 to the 0 power, because it's common log to this exponent, equals the y squared plus 2y over 8. 10 to the 0 is 1. Multiply both sides by 8. Now what I'm going to do is minus the 8 back to the one side. So I have this quadratic of 0 equals y squared plus 2y minus 8. Now I need to factor if possible. This one factors. I hope everyone remembers how to factor. I've put some of those in the spiral reviews. So again, what I want to do is find two numbers that, oh, that should be a y, by the way. Two numbers that multiply to give me -8, but add to give me +2. So that's going to be a +4 and a -2. So my two solutions will be the opposite of what you see. Y will either equal -4 or y will either equal 2. So I come up here and type in -4, 2. So that should be about as hard as they get. If you have questions on how to do this, please do bring them to class and I will help you work through them.